In the previous lesson, we derived an expression for the displacement of B with respect to A, and xB with respect to A is xB minus xa. This tells us the displacement of B as seen from A's perspective. Now A and B are both moving, and we want to find the velocity of B with respect to A mathematically. That is, from A's perspective, how fast is B moving? Mathematically, this would mean what is the rate of change of the displacement x B with respect to A? Let's attach the frame of reference to the bird or the observer. The observer measures the velocity of A and of B from its frame of reference, which is the ground, since the observer or bird is stationary here. So all the calculations are based on how the observer or the bird is seeing things. Using these velocities of A and B with respect to the ground, let's compute the velocity of B as perceived by A or V B with respect to A. If we differentiate the relative displacement equation with respect to time, we obtain the derivative of xB with respect to A as the derivative of xB minus the derivative of xa, all with respect to time. We obtain the relative velocity of B with respect to A as the velocity of B with respect to the ground minus the velocity of A with respect to the ground. It is very similar to the relative displacement equation, and as was mentioned in the previous lesson, the relative displacement formula is the only one you really have to keep in mind for this chapter on relative motion. The relative velocity and relative acceleration formulas will actually resemble the basic relative displacement formula, since they will just be the first and second derivatives. And in this particular example, since xB is increasing at a faster rate than xa, it will logically follow that the velocity of B will be greater than the velocity of A. We are given A's velocity as 3 meters per second and B's velocity as 7 meters per second. What is the velocity of B with respect to A? Now in the next step, we will use the formula that we had derived for relative velocity. So really, we are now trying to imagine what A will perceive B's velocity to be when A itself is moving with a velocity of 3 meters per second. The relative velocity of B with respect to A, or V B with respect to A, is VB minus VA, and we are given VA as 3 meters per second and VB as 7 meters per second. So substituting in the formula, we obtain VB with respect to A as 7 minus 3 or 4 meters per second. This means that A feels as if B is moving further away from himself at the rate of 4 meters per second. But according to the bird, B is moving at a much faster rate of 7 meters per second. So you can see that both these observers, that is the bird and A, are viewing B from their own frame of reference and seeing the movement of B differently. So relative velocity does depend on the frame of reference. Now let's try one thing. Let's actually step into the shoes of A and see how A sees both B and the pole. So we will have to fix the frame of reference to A. Now the frame of reference is fixed to A. So A considers himself to be at rest, and A sees B moving at 4 meters per second to the right, not 7 meters per second as seen by a person on the ground, but at 4 meters per second, and that is the meaning of V B with respect to A. And also check out what happens on the other side. Because A is now considered to be at rest, A sees the pole and the bird moving away from him at 3 meters per second in the negative direction. And this is the physical significance of V P with respect to A. Notice the difference. A person stationary on the ground sees A moving at 3 meters per second to the right and B moving at 7 meters per second to the right. But when we fix the frame of reference on a moving A, which is already moving at 3 meters per second, the picture is different. Since A is now considering himself to be at rest, he sees B moving at only 4 meters per second to the right, and he also sees the pole and bird moving at 3 meters per second to the left. And back into the stationary bird's frame of reference. The viewers of this video have to consider their frame of reference as the bird's frame of reference, which is stationary. A very important point at this stage is that while the relative displacement does not depend on the frame of reference, the relative velocity does depend on the frame of reference. A and the bird see B's velocity differently. When you check the relative displacement of B with respect to A, it would be the same from the ground frame of reference or from A's frame of reference, but the relative velocity will change based on the ground frame of reference or A's moving frame of reference. The relative velocity between two objects is the difference in their velocities from the ground frame of reference. The relative velocity is dependent on the frame of reference, unlike the relative displacement, which was independent of the frame of reference.